The next two examples we want to work through may seem initially quite similar to the previous three, but there's one important distinction, is that now we're dealing with polynomials of the form ax squared plus bx plus c, where a is some value not equal to 1. Meaning in each of these cases, there's going to be a leading coefficient that's something different than 1. As soon as we see that, that should indicate to us that we have a little bit more work ahead of us in order to get to a final answer. There are different approaches, but one we're going to look at is referred to as the AC method. What we do is take our values for A, that leading coefficient, and C, the constant at the end, and multiply those together to get 15. And then we look at what our value for B is, which in this case is 16. And then we try to come up with a pair of numbers that will multiply together to give us 15 and add together to give us 16. In this case, that pair would be 15 and 1. So 15 times 1 would give us 15, and 15 plus 1 would give us 16. We'll proceed from there by rewriting the original problem and taking our middle term, which was 16x, and breaking it up into two terms, 15x plus 1x, or just x. This means we haven't changed the original problem because 15x plus x would be 16. We're just rewriting it in a convenient way that will allow us to get to our solution. Then what we'll look at doing is factoring by grouping, looking at the first two terms and the last two terms. From the first two terms, we can factor out 3x, which will leave us with x plus 5. From the second pair of terms, there's nothing that we can factor out, so this will just remain as x plus 5. But if it's convenient, you can always think about the idea of there being a 1 out in front, or the idea that we factored a 1 out from that pair. To know that we're on track, the expressions we have left over inside parentheses should match each other exactly, meaning it's common between the two terms that we have, and we can factor that out, leaving us with, in this case, just the 3x, and that 1 that we had floating out in front of x plus 5. And this gives us our fully factored expression for this polynomial function. We'll look at one more example of this process. Again, we want to look at a times c, which in this case will be negative 18, and our value for b, which would be 3. The pair of numbers that we would want in this case would be 6 and negative 3. Since 6 times negative 3 would give us negative 18, and 6 plus negative 3, or 6 minus 3, would give us positive 3. Coming up with this pair of numbers can really just come down to a bit of trial and error as you consider different factors and terms that would give us these results that we're after. Taking the same approach as above, we'll break this into 2x squared plus 6x minus 3x minus 9. And then again, we'll look at factoring by grouping. We'll consider the first two terms and the last two terms. Between the first two terms, we can factor out 2x, which will leave us with x plus 3. From the second two terms, we can factor out a negative 3, which will leave us with x plus 3 once that sign flips. Again, the expression that we have inside the parentheses are identical, so we can factor out that quantity x plus 3, and what's left over is 2x minus 3. Again, as soon as we see a leading coefficient that's anything besides 1, we're going to have a little bit more work ahead of us where we have to break up this middle term and apply factoring by grouping. we're looking for the quantities inside those parentheses to match. And it's a really good idea in every case where you're factoring, but especially with these problems, to expand this out and make sure all three terms end up matching your result.